Okay, page 664, number 31, express the rational number as a fraction of integers. So we have 7.141414, continuing on and on and on. What's great about this example is it gives a meaning to the reasoning you've been given of why a repeating decimal is considered rational, because it can be written as a fraction. So really what a repeating decimal is an infinite geometric sequence that converges. So we're going to treat it as such. So we have to have an R. So in this case, we're going to have that our A is going to be 0.14, and we'll add to that the 7, and that our R, since every time we're moving over 2 decimal places, we're multiplying by 1/100th. So we can write out our number in this way to see it as a geometric sequence. Geometric series is 7 plus 0.14 plus 0.0014 plus 0.000014 plus 0.00000014, etc. Like that. So we're going to use our formula for the sum of an infinite geometric series. S equals A over 1 minus R. So we get 0.14 over 1 minus 0.01. And when you simplify this fraction, you get 14 over 99. So all we have left to do, that takes care of this much of our number. We have to add to that 7, and we just have to simplify this. So changing 7 into a fraction with 99 as denominator, we get 693 over 99, and to that we're going to add the sum of our infinite geometric series, 14 over 99. So 7.1414 repeating can be written as the fraction 707 over 99.